What will power our future? How will we heat our homes, light our cities, and deliver energy for industry? How will we combat climate change? What can we do about limited landfill availability? There is no single solution, however, schemes promoting the capability of energy from waste have gained momentum in recent years, since they have the potential to do all of these things, whilst protecting our environment, producing new jobs, and securing a sustainable future.
There is increasing global demand for commercially proven approaches of waste disposal and energy recovery. The amount of municipal solid waste, also known as MSW, being generated has increased exponentially due to population growth. It is estimated that 1.3 billion tonnes of MSW is produced annually, forecasted to rise to 2.2 billion by 2025. MSW contains huge amounts of useful energy, mainly derived from packaging, which until recent years has been lost to landfill.
Incineration is a means of recovering energy from MSW. The waste is fed into the incinerator, whereby large stoichiometric amounts of air burn the MSW. This process also produces large amounts of pollutants. The heat generated by incinerators is used to produce steam to generate electricity for the grid. The process leaves behind ash that must be carefully disposed of in landfills. Gasification is a cleaner alternative to conventional incineration and works in a fundamentally different way by employing two-stage combustion. In the first stage, gasification doesn't actually burn the MSW. Instead, it breaks the molecules apart at high temperatures of around 1600 degrees Celsius, using limited amounts of air or oxygen as the gasifying agent. These pylarized molecules are then recombined through endothermic reactions to form syngas. Syngas is a clean fuel commodity mainly composed of hydrogen, carbon monoxide and methane, and is similar to natural gas. It can be used directly as a fuel commodity or as a feedstock in the manufacture of downstream fuels and chemicals.
Comparing these two technologies, gasification prevents the production of nitrogen oxides and sulfur oxides. The higher temperatures also prevent the formation of dioxins and furans, which would normally be produced in incineration. Gasification also achieves a higher conversion efficiency of up to 30%, as opposed to incineration that can achieve a maximum of 24%. Furthermore, gasification plants have a capital investment saving of over 30% compared to incineration plants. They also have lower operating and maintenance costs.
In the slag, the recoverable metals can be beneficially used in cement making or as an aggregate for construction materials, allowing for greater potential revenue. Gasification is up to 18% firmly more efficient than incineration. Hence, gasification is an advanced option when it comes to energy recovery from MSW.
An example of such a gasification plant is Energos's 1.8 megawatt electric plant in the Isle of Wight. The project cost £10 million, 2.7 million of which was funded by DEFRA. It has been operational since 2009 and processes around 30,000 tonnes of RDF per annum. The RDF process is derived on-site to produce a high-quality contact fuel of around 80% with a calorific value of up to 14 megajoules per kilogram. It was the first gasification plant to be commissioned in the UK, whereby Energos's great gasification system was retrofitted into a small conventional incinerator plant that was originally located on-site. In 2010, there was a problem regarding the emissions exceeding the EU limits. However, after modifications, this problem was resolved. The plant is currently operating at an availability of around 80% per annum, at an efficiency of 85% as a CHP, and thus far has been deemed a success.